Hi guys, welcome back to Cloud Tech. In this video, I'm going to discuss some interview questions which were asked in one of the interview which was recently conducted by Capgemini. The candidate was a Java full stack developer and he was having 3.8 years of experience working as a Java full stack developer. Okay, so when I say it was a Java full stack profile, he was having a knowledge about Java, he was having knowledge about Spring Boot, he was having knowledge about REST APIs and microservices. Apart from these backend technologies, he was having knowledge about UI technologies like Angular, HTML, and CSS. So when he was selected, he was offered a CTC of 16.5 LPA. Okay, now let me tell you what were the questions which were asked into the interview. So he was asked a few query questions related to Java, Spring Boot, microservices, and Angular. Apart from this, he was given a Java tricky coding problem to solve. So I'm going to share one solution with you guys, and you guys can provide me the other solution by which you can solve the Java problem statement. Then he was asked to guess the output for the given code snippet. So he was provided a piece of code and he was asked to find what will be the output of that code snippet. Okay, so I'm going to share all these questions with you guys and you can prepare with these questions. Okay, let's get started. So the first question is what are the microservices and how they are different from the monolithic architecture? So this is the first question which was asked into the interview. So basically these microservices is an architectural style where an application is composed of small, independent and loosely coupled services that work together to fulfill specific business capabilities. So each microservice represents a small unit of functionality that can be developed, deployed, and scaled independently. Okay, so these microservices communicate with each other through a lightweight protocol, and that protocol is nothing but the APIs. Okay, so here I have listed some key differences between the microservices and monolithic architecture. The first one is size and complexity. In monolithic architecture, the entire application is built as a single tightly coupled unit. This means that all the components of application are tightly integrated and share the same code base. In case of microservices, these microservices are smaller and focused on specific business capabilities. So each microservice has its own code base, it has its own database, and that can be developed and deployed independently. So that is the first difference. Second one is scalability and agility. So monolithic applications usually require scaling the entire application, even if only certain part of your application requires a change. Okay, so with microservices, you can scale individual services independently based on their specific needs. It allows better resource utilization and cost efficiency. So microservices also enables faster development and deployment cycles, as each service can be developed and deployed independently without affecting the entire application. So that is the second difference. The next one is fault isolation and resilience. So in monolithic architecture, a fault or a failure in one component can impact the entire application, but that is not the case in case of microservices. So failure in one microservice does not impact or does not affect the entire system. Okay, so this improves overall system resilience and makes it easier to recover from their failures. That is the third difference. Then we have technology diversity. So in monolithic applications, basically we use a single technology to develop the entire application. Okay, but in case of microservices, microservices allows for technology diversity. So each microservice can be developed using different technologies, using different frameworks or any databases based on their specific need. Okay, so that is the fourth difference, technology diversity. Then there is team organization. Okay, so monolithic applications often require large development teams working on a shared code base, whereas microservices promote a decentralized development approach where small teams can independently develop, deploy, and manage their own microservices. So this allows for more autonomy and faster decision making. And the next one is deployment and scalability. So monolithic applications are usually deployed as a single unit, making it challenging to scale specific components independently. With microservices, you can deploy and scale individual services based on their specific needs. Okay, so these are the few differences which are there when we compare the microservices architecture with the traditional monolithic architecture. The next question was, what are the some challenges which can occur or which are associated with microservices implementation? Okay, so here I have listed few challenges which can occur while implementing the microservices. The first one is a distributed system complexity. Okay, so microservices introduce a distributed system architecture which brings complexities. So managing communication between services, ensuring data consistency, handling failures, and maintaining the overall system's reliability can be a challenging task. The next one is service coordination and orchestration. Okay, so as the number of microservices grows, coordinating and orchestrating their interactions becomes more complex. So implementing mechanisms for service discovery, load balancing, their inter-service communication requires careful planning and consideration. The next one is data management and consistency. So microservices typically have their own databases or their own data stores. So ensuring data consistency and maintaining data integrity across multiple services can be a challenging task. The next one is deployment and scalability. So deploying and managing multiple microservices across different environments can be a challenging task. So ensuring proper scaling, monitoring, and managing the overall system's performance require effective deployment strategies and appropriate infrastructure. So maintaining this deployment and scalability can be another challenge while implementing the microservices. Then service dependencies and versioning. So microservices often rely on other services, creating dependencies between them. So managing these dependencies and handling versioning becomes critical. Okay. So to avoid these compatibility issues and ensure smooth upgrades and deployments, these microservices dependencies managing can become a tedious task. Then service discovery and load balancing. So in a distributed environment, discovering and dynamically routing requests to the appropriate service can be a challenging task. So implementing service discovery mechanisms and load balancing strategies is a crucial for effective service communication. So that can be again a challenging task. Then testing. Testing microservices involves validating the interactions between multiple services, which can be complex. So ensuring comprehensive test coverage, including your integration testing, contract testing, end-to-end testing, it becomes essential to maintain the overall system's reliability. Okay, the last one is monitoring. So monitoring the health, performance, and behavior of each individual microservice can be a complex task. So these are the some challenges which we need to keep in mind while implementing the microservices. So that was another question which was asked into the interview. The next question was, how do you ensure the data consistency in your distributed microservices environment? So these are the some strategies that can help to ensure data consistency in a distributed microservices environment. Okay, so the first one is database per service. So each microservice should have its own dedicated database or data store. This ensures that each service has full control over its data and can enforce consistency rules within its boundaries. The second is synchronous communication. So for critical operations that require immediate consistency, use a synchronous communication between microservices. So this ensures that all necessary updates are applied and acknowledged before proceeding with the next operation. The next one is distributed transactions. So in cases where strong consistency is required across multiple microservices, distributed transactions can be used. However, implementing distributed transaction is complex and can have performance implications. Okay, The next thing that can be used to ensure data consistency is Saga pattern. Okay, so you should implement a Saga pattern to maintain data consistency across multiple microservices. Basically, this Saga is a sequence of local transactions where each transaction updates the data within a single microservice and publishes events to trigger subsequent transactions. So Sagas ensures that either all transactions within the Saga are succeeded or failure. Okay, then the next one is idempotency. So you should design microservices to be idempotent, meaning that performing the same operations multiple times produces the same result. Okay, so this helps to prevent duplicate or conflicting data updates in case of your retry or failure operations. Okay, the next one is event driven architecture. So you should use an event driven architecture where microservices communicate through an asynchronous bus or asynchronous events. So by using this event bus or a message broker, microservices can publish events and subscribe to relevant events to update their data accordingly. Okay, so this allows for loose coupling and eventual consistency. So these are the few strategies that can be used to ensure data consistency in your distributed microservices environment. Okay, the next question was related to the Java. So he was asked, is a Java pass by value or a pass by reference? Okay, and he was asked to explain the concept of this pass by value in Java. So Java is strictly pass by value. It was never a pass by reference. Okay, so when I say it is a pass by value, which means that when a method is called, the value of the arguments are copied and passed to the method. So here I'm passing the values of the arguments, okay, instead of references. Okay, so if you look at the example, in this example, we have a method change value method. Okay, that takes an integer argument, which is value. So this change value method takes an integer argument, which is value. Okay, so when we call this method with variable x, Java passes the value of x, which is 10, to this value parameter of the change value method. So when we call this change value method, we are passing the variable x with value as a 10. So Java passes the value of this variable x as a 10. Okay, but inside the method, the value parameter is a separate local variable that holds the value of 10. So when we assign 20 to this value parameter, it does not affect the original value of x. So if you assign the value 20 to this value parameter, it does not impact the value of this variable x. So when you will execute this statement, this will print the value of x as a 10. Again, if you call this function and execute or print this statement, it will again print the value of x as a 10 because Java is pass by value. Okay, so both the time you will get the output or the value of x as a 10. Okay, even though Java is pass by value, when you pass objects as an argument, you are passing the value of reference to the object. Okay, so that is about the pass by value and pass by reference. So in summary, you can call that Java is strictly a pass by value language. Okay, so you are passing only values to the method parameters and not the references. Okay, so the next question is, what is the difference between hash map and hash table, and when we should use hash map or hash table? Okay, so hash map and hash table actually both are the implementations of the map interface in collection framework. So I'm going to discuss these four differences between this hash map and hash table, and then we will see when we should go for hash map and when we should go for hash table. So the first one is synchronization. Okay, So hash table is synchronized, which means that it is thread safe for concurrent access. So multiple threads can manipulate a hash table simultaneously without causing data corruption. Okay, on the other hand, hash map is not synchronized. Okay, so it is more efficient for single threaded application. Next one is null values. So hash table does not allow null keys or null values. Okay, if you attempt to store a null key or value, it will throw a null pointer exception. But in case of hash map, it allows you to store one null key and n number of null values. That is the second difference between your hash map and hash table. The next thing is performance. So hash map is generally faster and more efficient than your hash table. Since hash table is synchronized, it incurs the overhead of acquiring and releasing the logs, which impact its performance. Okay, so in scenarios where synchronization is not required, using hash map can provide you a better performance. Okay, so that is the third difference. And the next one is iteration order. Basically, both hash map as well as hash table does not guarantee the iteration order of elements. It may vary based on factors like resizing, collision, and hash code. Okay, so if you need a specific iteration order, then you can consider a class like linked hash map. So these are the few differences which you can mention while answering the questions related to hash map and hash table. Now, if you consider these characteristics, you would choose hash table when you require a thread safe operations. But on the other hand, if you are working with a single threaded application or you need better performance, I would suggest you should use hash map. That is the better choice than your hash table. Okay. The next question which was asked in the interview was related to Java, and it was, can you override a private or static method in Java? So the answer to the question is no, you cannot override a private or static method in Java. Let us discuss why. So let us first understand what is private methods, and then we'll see what is static methods, and then we'll see why this cannot be overridden. So first thing is private methods. So private methods are declared within a class, and those are not accessible or not visible outside the class. Okay, since they are not inherited or accessible by subclasses, you cannot override them. Okay, each class has its own private methods and they are meant to provide internal implementation details specific to that class only. That's the reason the private methods cannot be overridden. Then static methods. So static methods also belongs to a class rather than an instance of your class. So they are associated with the class itself and not with any particular instance. So in Java, static methods are resolved at compile time by your compiler. Okay, rather than runtime on the actual object type. Therefore, these static methods cannot be overridden. Okay, so you can say that private and static methods cannot be overridden in Java. Then the next question was related to a Java coding. So he was asked to write a Java code to print 1 to 100 numbers, but without using any loop. Okay, now let me show you how to do this by one of the approach, and you can show me or you can tell me the other approach. Okay, so here you can see I have written a class print numbers, and inside that I have written a main method which is going to be starting point for our program execution. Okay, so here what I'm going to do, I'm going to write a function which will be used to print the number. So here I will write public static void print numbers, and here I'm going to accept an argument which will be my number, and I'm going to print this number. Okay, so here what I will do, I will check if the number is less than or equal to 100, then I have to print that number. So sys out, and I will print that number. Okay. Once I print that number, I need to call this method again so that this number will be incremented by 1. Okay, so here what I will do, I will call this method recursively again and pass the next number. Okay, now I need to call this method when we start the program execution. So what I will do, I will copy this and call this main method from the main method, and I will pass the starting number as a start value. So we have to print the numbers from 1 to 100. So here I am passing 1 as a starting point. Okay, so what will happen when I call this method? It will come here. It will print the number n will hold the value as a 1. Now here it will come. It will check whether n is less than or equal to 100. So n is 1. It will print the system.out.println. So it will print the value of n, which is going to be 1. And then again it will call the print numbers function, which will be 1 plus 1. So next time this n will become 2. Again it will check whether the n is less than or equal to 100. This time n is 2, and it will print the n value of n. It will become 2, and again the value will be incremented by 1, and the subsequent calls will happen until the value is less than or equal to 100. So it will print the values from 1 to 100. Okay. Now let me run this program and show you the output. So here you can see we are getting output as the numbers from 1 to 100. Okay, so this is one way by which we can print the numbers from 1 to 100 without using any loop. Okay, so that is one solution. You guys can provide me the other solution. Now the next question which was asked in the interview, which was related to the code snippet. He was provided this code snippet, and he was asked to guess the output. Okay, so if you see this code snippet, here we have written a main method, and inside that main method there is an expression. Okay, so he was asked to guess what will be the value of this expression. Okay, so once this expression gets evaluated, the value of this expression will be stored inside this str variable, and that will be printed on the screen. So what will be the output of this expression? You have to tell me in the comment section. Okay, and here is a list of Angular interview questions which were asked into the interview. So he was asked to explain the concept of lazy loading in Angular and what are the benefits of lazy loading. Then the next was related to the pipes in Angular. So he was asked to create a pipe, and he was asked to provide some examples of built-in or ready-made pipes which are available in Angular. Then he was asked what is the use of services in Angular and how the components communicate with each other. Then he was asked the Angular components lifecycle hooks. So there are certain methods which you need to prepare as an answer to this question. Okay. Then he was asked what are the directives in Angular, so what are the different types of directives and the examples of built-in directives or predefined directives. Apart from this, he was asked how to create a custom directive. Okay, so these were some questions which were asked into the interview, and when he answered all these questions, he was selected and he was offered a CTC of 16.5 LPA. Okay guys, so that's it from this video. If you like this video, please like, share and subscribe. That will motivate me to create more videos like this. Thank you. Bye bye.